Greetings and welcome, Mr. Waddy here, going over some of your homework from Algebra 2, 10.1, Sample Spaces and Probability. Here it says you flip a coin and draw a marble at random from a bag containing 2 purple marbles and 1 white marble. So let's see, for flipping a coin, yeah, that's better. Heads or tails are the possible outcomes. And usually your first branches you kind of want to have spaced out so that way you can figure out the rest. And then draw a marble. And so notice there are 2 purple marbles. And so I'm going to have PPW, purple, purple, white. You could specify whether it's purple 1 or purple 2, but the only point of representing it this way is that it's kind of twice as likely to draw a purple there. So you've got to represent both of those possibilities. And so the total number of outcomes, sample space, there are 6 ways that this could happen. Which I believe if you're doing this digitally on Big Ideas, they're not looking for the list, they're looking for the total number of ways. Close enough, same diff. Alright, here's question 6. You draw 2 marbles without replacement. And we're going to talk more about that in the next section. From a bag containing 3 green marbles and 4 black marbles. And so our first scenario, let's see. So there's 7. So the first choice, so 2 marbles, this is choice 1. So I could have green, 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 black, 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 and black. And yeah, it's not a bad idea to try to space those out. And then the second time you draw, and the keyword without replacement. And so originally there were 1, 2, 3, 4, 5, 6, 7 marbles in the bag. If I don't put it back, how many are still in the bag? That would be 6. And which ones are still in the bag? Well, that depends on what the first drawing was. And so if the first marble was green, there's 1 less green. Right? There's only 2 green instead of 3 to pick from. And then, let's see, for sake of spacing, I'm going to write 4B. Boom. Right? Boom. And this would be the same. So this would be, right, 2 green to pick from and 4 black. This would be 2 green and 4 black branches. Now, if the first choice was a black, there are now 3 green to pick from, and instead of 4 black there would be just 3, because right, like one of them would have been picked, and so 3 green, 3 black. And so I'm trying to save myself drawing so many branches. And so this without replacement did change the possible outcomes in the end. So that's a little bit weird. And so the total possible ways, I would count up the tips of the branches here. And so I would have, what's that? There were 6 times 6, 36 ways. Did I do that right? No. Here we go. There were 7 here and 6 after each choice. So 7 times 6, so that's 42 ways that could occur. Boom. Haha. Yikes. There we are. All right, let's keep cruising. Your friend has 2 standard decks of 52 playing cards. Go check out, right, standard decks of cards on Wikipedia or something. So I apologize if your personal life has not allowed you to become familiar with what these terms mean, which obviously could be the case. So it says, and asks you to randomly draw one card from each deck. What is the probability that you will draw 2 spades? And so, if I want to figure out this 2 spades probability, wait a minute, 2 standard playing card decks. I'm trying to think of how to set this up. Draw one card from each deck. Aha, ha ha. All right, okay, because I was starting to worry if I had to do the replacement thing. What is the probability that you will draw 2 spades? So spades are one of the 4 suits in a deck of playing cards. There are 13 in the first deck out of 52, and then 13 in the second deck out of 52. Man, oh dear. I'm accidentally going in the direction of... I'm approaching this using a skill that I haven't taught you yet, and so now I'm worried. Draw 2 spades. So it would be 1/4 times 1/4, right? Which is 1/16. I don't like that I'm teaching you this way. Yeah. So there's a 1 out of 4 chance that you'd get a spade on the first one, and a 1 out of 4 chance that you'd get a spade on the second one. You end up multiplying those, which is kind of, I guess, we kind of described that here, right? There were 7 outcomes here, 6 here, and I multiplied 7 by 6. I guess we're kind of like beginning to dabble in that. But because these are independent events, we'll call it, you can multiply their probabilities. So it's a 1 out of 16 chance, which is 6.25% chance that you get 2 spades. Man. Yeah, there's a few different ways you could set this up. I'm going to be content with that one for now. Let's keep going. Question 10. The age distribution of a population is shown below. Find the probability that a person chosen at random is at least 15 years old. Let's see. I'm going to screenshot this so I can doodle it up twice. Here we go. So at least 15 years old. So here's ages 5 to 14, under 5, and then they've got everybody else. So 15 years or older would be talking about this slice of the pie. And so I could go about adding all of these values together, these percentages together, and that would give me that total slice. That's one way I could do it. I could also do it by using the smaller slice, so the not A version. So that's 20%. And so this probability would be 1 minus 20%, which equals 80% chance that someone is at least 15. There it is, at least. So 15 or greater. And theoretically, if I added up all the green, that also would have been that. How about the probability a person chosen at random is from 25 to 44? All right, and so here's 25 through 44. So here's my successful region. So that's 13 and 13. So that's just going to be 26. Oh, this already is a percent. If I did 26 and then added them all up, that would have, the total possible outcomes would have been out of 100 anyway. So there you go. So yeah, bunch of ways you could do that as well. I think, is this my last one? No, I've got 2 more. There we go. Drawing conclusions. A bag contains 5 marbles that are each a different color. A marble is drawn, its color recorded, and then the marble is placed back in the bag. Aha, 30 total are drawn. Okay, and so that's our total number of trials done in this experiment. The table shows the results for which the let's see. Did it say? Yeah. Contains 5 marbles. Each is a different color. Okay. So yeah, it's either white, black, red, green, or blue. Very good. Out of 30, yes, yes. Out of 5. So the theoretical probability, the theo probability of any color would have been 1 out of 5, or 20%. Now the experimental probability of getting one of these colors, right, this would be like getting a 5, and I guess I'll write it this way. So 5 out of 30, that reduces to 1/6, okay? 6 out of 30 is 1/5, and so that's the same as 20%. And so the final answer ends up being black. This is the situation in which the experimental probability happened to match the theoretic probability. 20, last question. A survey of, oh, that's nice of them. That's my total. 2,392 adults, ages 18 and over, are asked what type of food they would be most likely to choose at a restaurant. The results are shown. What is the probability that an adult chosen prefers Italian food? Italian looks like this is right here. So here's my success. So I'm going to say 526 divided by 2,392. And probability works because random person, okay, is the key. And so I do 526 divided by 2,392. And I get a 21.99%. So 21.99% chance that a person likes Italian food is their favorite. Well, all right. Well, thanks for watching, Internet friends. Have a great day. Bye-bye.